In this section, we're going to be introducing the Venn diagram. This is a type of diagram which can be useful when dealing with sets and can be adapted to work with probability when dealing with events. The rectangle here represents something called the universal set. This symbol means universal set. The universal set sounds like it must be a vast collection, but actually it just contains everything under consideration at this time. Therefore, a universal set may be a very large collection, an infinite collection, such as all numbers, but it could just be the people in your class. Equally well, in another situation, it could just be the numbers from 1 to 6. Let's suppose that our universal set was the integers from 1 to 10. That means that all of these integers need to appear somewhere within the rectangle. So to draw this situation, we simply write the numbers from 1 to 10 somewhere within the rectangle. Here our universal set is the same, the integers from 1 to 10, and we're given A and B. A is the even numbers from 1 to 10, and B the prime numbers between 1 and 10. These are called subsets. They are sets contained within the universal set. We represent these by ellipses within the universal set. This would be A and this B. If we consider these, we can see that 2 is in both sets, since it is even and prime, and therefore 2 goes in the intersection between the two sets, and you can see the 2 is both within the A ring and the B ring. None of the other even numbers are prime, so they go in this section where they're within A, but not within B. None of the other prime numbers are even, so they go in this section so that they're within B, but not within A. There are 2 numbers left here, and they would go in the outside section. So 1 and 9 go outside. They're within the universal set, i.e. within the rectangle, as they have to be, but they're outside of both A and B, since they don't belong to either of these sets.